Well, we should definitely talk about this more, but maybe like not when the cameras are rolling so our competitors don't hear the conversations that happen after we cut.
You heard it here first.
Live, it's live.
Live. Welcome to the Dutch Podcast, where we dive deep into the science of hormones, wellness, and personalized healthcare. I'm Dr. Jaclyn Smeaton, Chief Medical Officer at Dutch. Join us every Tuesday as we bring you expert insights, cutting-edge research, and practical tips to help you take control of your health from the inside out. Whether you're a healthcare professional or simply looking to optimize your own well-being, we've got you covered. The contents of this podcast are for educational and informational purposes only. This information is not to be interpreted or mistaken for medical advice. Consult your healthcare provider for medical advice, diagnosis, and treatment. Hi, everybody, and welcome. I'm so excited that you're joining us here for our first live podcast from this year's APharm event at the Venetian in Las Vegas. I'm Dr. Jaclyn Smeaton, your host of the Dutch Podcast and Chief Medical Officer at Dutch. Today, we're joined by our wonderful Mark Newman, founder and CEO of Dutch, and our special guest today, Kara Fitzgerald, Dr. Kara Fitzgerald. Kara, I have a copy of your book to show here.
Cool.
Kara is the author of Younger You, Reduce Your Bioage and Live Longer and Better. And really, you're a naturopathic physician by background, and I would just say a mover and a shaker in this field, moving through clinical trials on really applying the foundational lifestyle techniques and targeted nutrition and seeing an amazing impact on age reversal in your patient population. We're going to talk about that. I don't want to jump into that. You know, Kara's also, Dr. Fitzgerald's also a renowned functional medicine clinician and researcher. And Younger You is not your only book. You're author of several books. And really leading as a pioneer in DNA methylation and biological age reversal, which is all the rage now. Media and the rest of the world has caught up with the work that you did, but really doing those clinical trials I can't wait to dive into. So welcome so much to the Dutch Podcast.
Thank you. It's great to be with you both,
Good to
of
have you.
course.
Well, I want to start by talking about your primary research. Can you walk us through like what inspired you to conduct this clinical trial and kind of talk us through a little bit about the trial?
Awesome. Yeah, absolutely. And we have a publication that came out based on that data, and we're working on a new one that came out this year. So make sure you circle back to that. Thinking about epigenetics really started to grab my brain. I want to say around 2013. It was a while ago. More and more papers were like passing across my desk, or PDFs, and so the question for me is always, how does functional medicine influence pathophysiology, influence mechanism? I'm always thinking through the functional medicine lens. I'm always thinking about how I might apply this to my patients. Is what we're doing best practice? Can we improve, et cetera, et cetera? So those questions, as a clinician at heart, kind of lab geek / clinician, are always really top of mind for me. And so the epigenetic data early on was primarily in cancer. Cancer takes over gene expression. It hijacks the tumor microenvironment for its own nefarious ends. So it will turn off protective genes that keep cancer at bay, the tumor suppressor genes, and it will turn on oncogenes. And this is primarily through DNA methylation. So turning off a gene, it's hypermethylated. A methyl group goes on, or multiple methyl groups will land on that gene and inhibit it from being expressed. And in the case of oncogenes, the methyl groups are actually removed. And the cancer microenvironment is incredibly efficient, and it reliably occurs across cancer. So much so is that you can measure if you've heard of the Grail test, there's DNA methylation to look at early evidence of cancer is just being widely adopted now because it's just a reliable measure for many different tumor types. It's quite interesting. So the question at that time for me, thinking about it through the lens of cancer and others, cardiovascular, et cetera, biological age at that time was thought not to be, was immutable. We didn't think we could change biological age as measured by the epigenetic clock. So back then we were really thinking about cancer and a few other things. But Romilly Hodges, the then director of nutrition, and she's still with me, she and I started to dialogue how we might interpret, manipulating this using a functional medicine approach. And so we designed that. We designed a dietary pattern. And then just our best read on the literature at the time. A lot of it was preclinical in animal models and cell. But we figured out that a methyl donor dense dietary pattern, lots of greens, lots, folate-rich nutrients, B12. We had people consume liver, eggs, beets, etc. Plus a huge complement of nutrients that are dense in polyphenols, green tea, herbs and spices, berries, etc. This combination dietary pattern plus, adequate fat, a good, a decent chunk of protein was the optimal for favorably changing gene expression in this way. And then we include exercise, we included a meditation practice, and we wanted people to engage in good sleep. During the course of our study, it was an 8-week intervention. The first publication showing that biological age can be reversed in humans came out during our study.
Wow.
We knew that we were going to look at that measure. We had the data to look at it, but I wasn't holding my breath that we would put the needle on it because it hadn't, we didn't have any human data on that prior to. But when that study came out, for me, for the space where people are thinking about biological age, epigenetics, and so forth, it was like time to tell. And that was the TRIM trial, Greg Fay's work. So we were excited to look at it. And so it was the first question that we asked of the epigenetic data we had. And, it was, I can't even tell you how exciting it was the moment that, our biostatistician informed me that we had in our study group reversed the biological age as compared to the control group by over 3 years in 8 weeks time. 8 weeks time using a diet and lifestyle intervention. I mean, we knew that we were onto something pretty special. It was the first of its kind study.
Yeah, it was really, the results were shocking as just a reader not participating.
Yeah.
Because it just goes to speak to, and it's something that I've always foundationally believed, the impact of lifestyle on health.
That's right.
That's what was so profound about this. This was a lifestyle-based intervention. It wasn't this targeted, amazing new supplement. This is something that anybody could do.
As Tina Kaiser, our fellow ND, said to me, God, carrots, just naturopathic medicine, It's true. It was true. And we were, at that time, a lot of us were talking about nutrigenomics and we were throwing out the idea of epigenetics, but the data weren't there for us to really say that strongly. And so just to be able to participate in creating new knowledge, to be able to participate in providing new knowledge to the, to the scientific pool was incredibly astonishingly gratifying. And it was, it was pretty like career change.
Yep. Oh, I bet.
After that, it was unexpected. It got a lot of attention. And then we went on to, write the book and we reproduced that in a smaller cohort of women. So the original study was limited to men. And then we published a follow-up looking at women and saw actually better outcome, but it's not quite an apples to apples comparison. The men we used saliva and the women we used blood. So the specimen was different, but the women really did fabulously well.
Tell us about the recent publication.
So we went back in to tease out what elements, if we could, of the whole intervention seemed to do the heavy lift on changing the Horvath clock, which is what we used. And it turned out to be those nutrients most dense in polyphenols. So the polyphenols. And what's really cool about it is, since that 2021 publication, so there was a scant amount of human data, but since then, the trajectory looking at dietary interventions, dietary patterns, and epigenetics and biological age, it's just has skyrocketed. And so it's very validating. It's very satisfying. Polyphenol dense dietary patterns like the Mediterranean and some with additional polyphenols added. Like we're really being validated in our original finding. And we went back and quantified the amount of polyphenols. We using our best, the best tools available to us. We didn't get specimen for those, but it's about 3 grams a day, just under 3 grams a day, which again, when you look in the literature, it's as dense in polyphenols as it comes.
And that was by way of supplement or dietary?
No, dietary. Yeah, dietary.
Okay.
Can we roll it back a little bit? And for people who are maybe listening for the first time and new to this area, what is a polyphenol?
Yeah, so it's a phytochemical. It's what makes it provides colors. When you're eating your berries or peppers, etc. It's a phytochemical that is what we call quote pleiotropic, meaning it does a lot of really cool stuff. It's not our macros. It's not a sugar. It's not a fat, a carb, a protein. There are these really important plant compounds that are associated with just improving the hallmarks of aging. So the breakdown process that happens during the aging journey, they've characterized like 12 major players. Polyphenols will improve those. Polyphenols tend to the microbiome. They tend to the mitochondria. They take care of, gut health beyond the microbiome. They help with brain health. They're antioxidant. They're anti-inflammatory. They're anti-cancer. They're just profoundly pleiotropic and important. It's why we eat, these plant-dense diets. It's a prime reason. It's to really consume a lot of this, what I call information, this incredibly important information. I think that the way these guys are working is, the most upstream location is that they're changing gene expression. And then there's these downstream benefits, these profound, far-reaching downstream benefits that we're seeing.
Are there a couple that people might recognize the name of?
Yeah, there's a lot. Listen, you're already eating a whole bunch of these polyphenols. Right. You're already eating, we call them epinutrients because they can change the epigenome. In the book, one of my favorite parts about the book is the appendix. It's the epinutrient appendix. So you could go in there, especially if you're somebody who hasn't sort of adopted a healthy dietary pattern, but you could go in there with a highlighter and be like, oh yeah, I eat that. Oh yeah, I eat that. Oh, I eat pepper. I put rosemary on my food. I love thyme in my spaghetti sauce or the sauce for that matter, the lycopene in tomatoes. But really famous ones we know, of course, are EGCG and green tea. What else? The curcumin and turmeric, rosmarinic acid in rosemary, thymol in thyme. It just kind of goes on and on. Resveratrol, again, lycopene, sulforaphane, as we were talking about earlier, is a real badass polyphenol. There's many, many of them.
And when you say polyphenol, obviously poly meaning many or whatever. So the action from those comes after those are broken down into their individual parts, which is just a great big mix of some known, some unknown compounds. Is that kind of the general way those work?
I would say, that's an awesome question. And there's, it's not called the dark matter of nutrition for nothing. It's such a good mark kind of a question. We don't have a lot of, we're still wrapping our arms around understanding. So some compounds appear to really work their magic directly absorbed. Some compounds have to be absolutely transformed by the gastrointestinal tract. And this is the family of postbiotic compounds. Compounds work in concert, and they're acted upon by the microbiome sort of collectively. But we also know that there's awesome data on standalone compounds. Like one of my favorites is Urolithin A. It's a postbiotic compound coming from ellagic acid and some other players from like pomegranate, some seeds, et cetera. So the polyphenols are liberated when you eat pomegranate, and actually the white part is more dense. One of the doctors in my practice will eat like the white part.
Wow, that is commitment.
I know, that's discipline, right? But it's still in the bread, the yummy, juicy part of it. And if you have the correct microbiome, you can liberate those polyphenols directly and transform them into urolithin A, and then it's absorbed. And then there's a ton of fabulous clinical data on it, engaging mitophagy, so just helping with mitochondrial turnover and biogenesis, and just lowering inflammatory markers, just even increasing muscle mass in sedentary individuals. The benefit of this one postbiotic compound are extraordinary and far-reaching, but a lot of us don't have the appropriate microbiome to be able to make it, and especially in the quantities that we need. But you can actually supplement with it. However, what I like to point out is this is one in a sea of the dark matter of nutrition. There are many more to come, but I do think it illustrates nicely the exquisite power and importance of these players. Our bodies evolved ingesting this information, transforming it, using it. Like our genetic apparatus expects this kind of information. And we've been away from it. And I think, it accelerates aging, it causes the chronic diseases of aging, the litany of problems that we confront. So polyphenols, I'm excited to see that we are able to tease out and identify those as doing the heavy lift. But we would still argue that, in the context of the dietary pattern, overall would be best practice.
I'm not surprised to hear you say that because, even when you think about that polyphenol rich diet, you're also getting fiber and you're getting, when you talk about the mechanisms required to use the polyphenols,
Yes, exactly.
they require a good
Yes.
microbiome. And there's
Yes.
other things that were
That's
not
right.
elucidated specifically in the study that almost support the use of the polyphenols. It's a family. It's like a family adventure.
That's right. Yeah, fiber is essential for a healthy microbiome. Yeah, all the other elements in the plant compounds, good fat, protein, adequate hydration, etc. Yeah, pulling out, and we removed pro-inflammatory food. So it really sort of gives the runway and the space for these healthy nutrients to kind of do their thing.
Can we talk more about urolithin eggs? That's something that I think is really rising in popularity. And
Yeah.
there's been interesting studies that have come out
Yes.
on the supplement form of urolithin A. I'm sure you are more aware of them than I am.
Yes.
Can you speak a little bit to that of like what the data is showing when it's used as a dietary supplement compound and how you would kind of compare that to the benefits of getting it through a whole food source?
Okay. Yeah, I can speak to the data. There's always more studies coming out in this arena. I mean, the company that's producing Urolithin A, they've just put a lot of intention and time and energy and money into researching it. And by the way, congratulations on your publications as well, you guys. It's
Thank you.
it's important. It's important, and it takes time and effort and all of that. And these guys have really, really made a commitment. I would say, the studies that have really knocked my socks off around Urolithin A include looking at sedentary older adults, improving VO2 max in this population. So sedentary, so they're not exercising, only prescribing the Urolithin A, 1 gram, and they increased VO2 max by about 10% on average. Not only is that massively statistically significant, but if you look at a chart and look at VO2 max associations with age, that's about a
And
About
VO2
a
max, that's
decade.
a breath measurement.
yes,
And
it's
they
a
use it
breath-
for like metabolic rate measurement.
Yeah, it can be. Yeah.
Okay.
And it's your fit, it's your respiratory fitness,
yeah.
and and in part, tracking with cardiovascular. Like, it's a really good longevity measure. And to be able to, in sedentary, non-exercising adults, improve it by 10% to me is really incredibly profound. They increased muscle mass in sedentary adults. This, you guys, is a postbiotic polyphenol compound. We're not talking about some kind of a crazy drug or gene therapy or something
Right.
like this. It's like this compound from polyphenol. They've lowered from pomegranate. They lowered CRP. They lowered a whole selection of cytokines. They have cool epigenetic data that's pre-publication. They improved immune fitness. They improved, the various T cell ratios. They God, what else have they looked at? They're if they haven't published, they're just about to publish a paper in elite athletes. So they're looking at different cohorts, but really pretty consistently, the data that they show, and they source it to its ability to engage in mitophagy, which then prompts mitobiogenesis. So like this mitochondrial recycling phenomena is kind of what they think is doing the heavy lift. I mean, I think it's multifactorial.
Is that particular example in the ballpark of what you can get through dietary sources, or are they supplementing with
They're supplementing it. So
with a lot, like more than you can get from dietary?
yes,
or,
more
okay.
than you could get. So they have a test that they really need to make available to clinicians where you can see whether or not you're making urolithin A. I am a producer. I'm proud to say I'm a producer, but I'm not producing. Proud to say I need a t-shirt, but I'm not making the quantity that they've been using in some of these studies.
You mean multiple people with the same dietary
If you're-
intake will make kind of like the equal thing where some people make it and some
Some people don't. That's exactly right. And
Because of
equal is
microbiome
it's
stuff?
it's a microbiome dependent compound.
Okay.
Yes, and there's a handful of different urolithins. Urolithin A seems to be perhaps the most important. But yeah, they're working with with a super physiologic amount in the supplement.
Okay.
However, there is data on urolithin producers and good outcome. Like they measured urolithins A, B, C, I think, in the direct study, which was a Mediterranean, the direct plus, which is a Mediterranean dietary pattern plus additional polyphenols. And they were able to see that they increased them naturally just from the dietary pattern. And that was associated with some of the good outcomes in that particular study. So you don't want to throw out the diet potential.
Yeah.
The challenge is that not all of us make it. So it would be nice to, just like Equal, because Equal is another really important player, and not a lot of us. I don't know that a lot of us make it.
Yeah, and lab guy wants to know. They look for that in urine, not in blood, or is it in urine that they're looking for that?
I think it's urolithin. Urolithin.
Yeah.
Oh yeah.
Very interesting question.
Urine.
Thank you.
I know where you're going with that.
That's a really
I
interesting
know where you're
question.
going with that.
Light bulbs,
Dude,
hold on. Okay.
That is a really good direction to take, because it's an important tool to be able to look at this. Not just the urolithins, but the other postbiotics, like going back to Equal.
Yeah.
Like that would be just to have that kind of panel, to see if we're making these, to see if we're making them in appropriate quantities, to begin to tease out, what polyphenols need to be transformed, what need to be absorbed directly. I mean, and then the absorption technology.
Yeah.
With curcumin, there's different ways of optimizing absorption.
Yeah. Well, we should definitely talk about this more, but maybe like not when the cameras are rolling, so our competitors don't hear the conversations that happen after we cut.
You heard it here first.
Live, it's live.
Live.
We'll be right back with more. If you're already running Dutch tests in your practice or thinking about it, there's never been a better time to become an official Dutch provider. Why? Because we go beyond lab testing. Our provider community gets exclusive access to clinical education, in-depth report interpretation training, monthly case reviews, and one-on-one clinical support. Whether you're just getting started or looking to sharpen your functional hormone expertise, we give you the tools to grow. Join thousands of providers already making a difference. Visit DutchTest.com today. Welcome back to the Dutch Podcast.
I'm going to develop the next panel. I want to talk a little bit about an element of the work that you did, because I think it's really interesting that you looked beyond nutritional data at stress and stress reduction and meditation.
Yes.
Mark, I'm hoping you can start, because I also think it's fascinating that we have HPA access as part of a panel that people think about for reproductive health.
Yes.
Can we start the conversation with you framing up why, when you think about hormone health, HPA access and adrenal function and cortisol are such an important part of that story?
Just generally?
Yeah.
I mean, I think that's a pretty good foundational place to start. Just thinking of reproduction, if you're getting invaded by the Huns, it's not time to make a baby. So our bodies are pretty smart that when that's going on and you're in flight or flight, then there's a whole bunch of stuff not going on.
Yes.
That obviously, if it's prolonged, then you're not going to get good outcomes. And then we live in this, over the history of the world, we live in such a weird space now where literally nothing can happen and those systems can be turned on almost all the time. And by this silly world we live in terms of just what's going on between our ears that can create fight or flight without the tiger chasing us around the room. So, knowing what's going on, and then when that happens, then you can have a spectrum of that's happening and I'm functioning properly, meaning I'm running hot because, lots of cortisol, lots of adrenaline, whatever. And then, of course, fast forward when your body's like, okay, that's about enough. We're going to shut that system down a little bit. So, so depending on where you're at in that kind of progression of being exposed to that in unhealthy ways for long periods of time, and then the consequences kind of, you're well aware, like roll off of that in many ways, and then you too as doctors get to pick up the pieces, decades later or whatever. But just the foundational thing that if it's off for prolonged periods of time, the consequences are many and pretty profound for lots of people. So
it blows my mind when you think about like stress and cortisol. I mean, every system of the body has been researched and that it's impacted by cortisol dysfunction. And what about aging? When it comes to aging, have they looked at that and the impact of stress on aging?
I'm so glad that you brought it up. I've said often that, stress, cortisol is like gasoline on the fire of aging. Like really, it is. And what was super interesting to me was the clock that we used has a lot of these what they call glucocorticoid response elements on it. So it's responding to that glucocorticoid, it's responding to the dump of cortisol, and it's very much pro-aging.
It's interesting that you say pouring gasoline on the fire, because I describe cortisol as a fire extinguisher. And like in its best form, in its healthiest state, it is.
Yes.
But then when you get too much of it, it has that reverse effect.
Yes. Yes. I think it is profoundly pro-aging. But yeah, to your point, short-term acute stress is one of the most powerful experiences we can have. Like go undertake a good athletic event or be challenged in some kind of a short-term kind of, controlled, for lack of a better word, manner. And it's incredibly, nourishing, powerful, and essential. And that's how we evolve. But then to your point, Mark, when we're in fight or flight in our heads, chronically, constantly, it's profound.
Yeah. Are there other elements of like crossover with the hormone impact around like polyphenol intake?
No doubt. I mean, for sure. There are just, a number of really beautiful polyphenols that will help balance out the transition. I mean, I was just talking earlier, to a group of people. I mean, we're here at the Venetian. I've been talking to a lot of colleagues. I mean, there was a time when women didn't experience the transition like as intensely and acutely, like it was relatively uneventful. And it was probably, and I think there's other parts of the world where, moving through menopause is not the challenge that we experience in this country and, in other countries. And certainly part of that is the dietary pattern. I mean, we know, sort of the polyphenols from soy, the polyphenols from clover. There's a whole host of polyphenols that will definitely ease the transition and help, maintain an estrogen-like environment, or, in other times, actually help metabolize out and clean up estrogen in premenopausal estrogen excess or dominant situations. So yeah, there's no doubt polyphenols in the context of an overall healthy dietary pattern.
Now you bring up a really interesting point about hormone metabolism. And one thing that I'd love us to cover today, maybe Mark, you can start us off, is that I think there's a lot of confusion because we talk about methylation, we talk about estrogen metabolism, and we also talk about methylation, we talk about epigenetics. And I get asked a lot, is this the same methylation? Are they connected? Are they not connected? Can you start, Mark, by talking a little bit about methylation in the context of estrogen metabolism?
Sure. Yeah. We actually, I think our most recent publication actually was a case study of me. And, I pushed my testosterone up, which made too much estrogen and it wasn't getting metabolized. So we used some nutraceuticals like DIM and I3C to push it down that 2-hydroxy pathway. And then me, being a genetic person who has the homologous COMT SNP, so my methylation sucks. Because I was loading up that 2-hydroxy, my methylation was even worse. And then we looked at trimethylglycine, like helped that. So there you have like nutrients that help methylation. In that particular case, you have COMT, which is the enzyme that's going to push my 2-hydroxy, that catechol, to be methylated, which then at the same time, I presume that's going on with epinephrine and other things that are catechols. So that world I live in, and it makes sense that there's a genetic component with an enzyme that's not, as I understand it, involved in the type of methylation you would talk about for epigenetics. But the nutrients, and this is where my knowledge gets super fuzzy, so epigenetic idiot in the room, that's me, is the nutrients like magnesium and methyl donors or whatever, things that are involved in the methylation of estrogen. So for people that use the Dutch test, the methylation is either going well or it's not going well. And if it's not, then they might want to encourage it. So it leads to these questions of like, okay, at the same time, in a parallel universe, in that same body, there's methylation going on with epigenetics, which might be either high or low, potentially differently, depending on whether it's a genetic source, like for me, or a nutrient source. So can you talk about where there's overlap between the two, like they're using the same cofactors, whatever, but then different enzymes. So as we push, like this is like a good question for our Dutch people, as we push methylation of estrogen metabolism, which we think of as being protective, and it is, what are the potential consequences that we need to be thinking about with with methylation going on in the epigenetic world?
Yeah, that's a great question, Mark. So they're all relying on the universal methyl donor, S-adenosylmethionine. They're all relying on it. So if we go back to the methylation cycle and you can see that the methylation cycle is wonky, maybe there's a high homocysteine, and I know we can measure, S-adenosyl homocysteine. We can dance around the methylation cycle with labs these days pretty efficiently, pretty well. So if that is not functioning, of course, you're going to see problems metabolizing estrogens, methylating them appropriately. You'll see problems clearing out epinephrine. We were talking offline. I think that there's a hierarchy. So there's precious SAMe of pool. When it's compromised, there's going to be preference. And I would argue that, something like epinephrine is going to, get that precious pool.
So methyl donors are universal. Right, so those are working everywhere.
Because that's a compound. It's like a chemical compound getting
if
added to some other chemical structure.
If you're in fight or flight, then those methyl donors presumably
are
getting snatched up.
Well, that's an interesting piece, bringing it back to what you talked about of stress pouring the gasoline on aging. Because if we need those methyl donors for detoxification and we need them for epigenetic expression to be optimized, and they're being dumped into a stress management system, they're unavailable potentially.
That's right. So if you're under a consistent toxic burden, that's an awesome point. You're going to spend your methyl donors. So homocysteine, even, outside of the methylation cycle, is the cysteine residue for glutathione. So it's going to just drain it towards glutathione if you're detoxing, really needing to grab that endogenous pool of glutathione. And that compound, when it's used to detox, is spent. You're not recycling it like when you use glutathione in a redox reaction where it can be like used over and over again. You're just spending it. So you could say that we're like our methylation cycle, our and then the the cysteinial cycle, the glutathione synthetic pathway, taurine, et cetera. I mean, we're always grabbing it. And it's going to be used preferentially for the most damaging. So I would start with epinephrine, and then maybe that, that mercury burden or whatever toxic compound that's going to be leaning on glutathione and some of the others is probably going to go towards that. Estrogen is like, survival's at stake here, maybe. I mean, this could be a piece of the estrogen dominance or the real imbalanced estrogen because this limited pool is going elsewhere. And I think by and large, of course, it's going to alter gene expression. It's going to alter methylation on the epigenome, the availability of SAMe to the DNMT, the DNA methyltransferase enzymes. So yeah, I mean, I would say in the hierarchy, that's probably, less essential in some ways for survival than some of the metabolizing out, adrenaline, metabolizing out toxins.
And the consequence of undermethylating in an epigenetic sense is what? You're not turning on genes you want to turn. Like, what is the consequence?
Well, I mean, it would be. I mean, I think that I think that it would be if you can't adequately methylate. I mean, or if you're doing it sloppily. Imbalanced methylation, imbalanced gene epigenetic methylation would be like pro-aging. I mean, you can look at the chronic diseases of aging. You can look at cancer. It would be allowing those things, like lowering the threshold, I would imagine, of really developing those things by not having an adequate pool.
I've got a great example of that.
Let me just say, I want to hear that, but I just want to throw in before the train leaves the station that we do our ability to methylate effectively, the epigenetically declines with age for sure. So that's known. But I want to just layer in this interesting point is that it actually becomes aberrant. It becomes imbalanced. So we turn off genes that protect us. we hypermethylate them like predictably on the aging journey, like those tumor suppressor genes I was talking about. So we'll take our, our reserves, our, cherished reserves of SAMe, and we'll turn off genes that protect us, and we'll allow genes that can drive disease forward to be turned on. It's pretty crazy. Like if you look at the aging epigenome and side by side it with the tumor microenvironment, in some cases they look really.
Well, one of the things that just makes me think about the agouti mouse model.
Yes.
And, what you're bringing up, Mark, around like, are there actually impacts of a deficiency in methyl donors? And that's been elucidated in animal research in a pretty interesting way. So there's this mouse model that's used for epigenetic research called the agouti mouse. The mouse looks like a normal, healthy mouse under typical circumstances. And then its kind of bad phenotype is fat. It's yellow coated instead of brown. It has heart disease, high cholesterol, basically the modern American. And they've done studies, for example, where they give the same mice, are genetically identical. These mice get the same amount of chow, and they were pregnant. That's the one study that's coming to mind. These pregnant mice given the same amount of chow, same quality, same nutrient density, same, quantity, same macros, and they were also exposed to BPA. Then they looked at the offspring. One parent.
The only variable was BPA?
No, they were both exposed to BPA. One of them had methyl donors in the diet added. So the only difference was one got methyl donors, which were, I think, folic acid they've looked at.
Betaine, folate, B12, choline.
And choline. That's what's coming to mind for me. So one mother group got that. Then they looked at the offspring. And what they saw was that the BPA-exposed offspring of the agouti mouse predominantly showed the unhealthy phenotype. The other parent's offspring that got the methyl donors with the exact same nutritional environment, their offspring had predominantly the healthy phenotype. And those offspring, it was 21 or 28 days after birth. This is a long time since I've looked at this data. The offspring got the same feed, the same quantity, et cetera. So it really made me think about our exposure as humans as well, and the importance of methyl donors in a preconception diet, which is kind of the lens that I view the world through, because we are all exposed to toxins that we don't know about. And I think the presence of methyl donors, when you think about things like childhood obesity, there's food quality issues that tell part of the story, but then there's also elements where you see cases where it just doesn't make sense. And you see kids that have, maybe in the same family, one of them struggles with weight and health and the other one doesn't. Well, you can look to in utero environment and methyl donors, and that preconception time is critical for epigenetic expression. So anyway, your conversation makes me think about that of there are studies, at least in animal models. I don't know, humans might be too complicated. You might know of some data, but where methyl donor presence or absence has made like a make or break piece of whether someone is really healthy or really, really ill.
Yes. And let me say the reason that the offspring did well under the circumstances with the BPA exposure is because the methyl donors hypermethylated and turned off the agouti. So specifically, it did. It probably helped. It helped with clearing out the BPA, I'm sure as well. But it shut that particular gene down. And when that gene is on, it's the obese blonde phenotype. So yeah, that's a great example. And they've looked at that. The agouti mouse model has been investigated in a lot of different arenas. Genistein was actually beneficial in one of the studies. But the wild thing about that paper, the whole agouti mouse research, is that other scientists took it on to see how many generations it would influence. So generation 0 gets it, the pregnant mom gets it. And then they look at it through generations. And I think up to 6 generations,
I heard 7 in one study. Yep,
influence. So that baseline exposure to those methyl donor nutrients influence gene expression 7 generations out in a mouse model. It's extraordinary. And we can see that. We can see that in human data as well. In populations that have experienced starvation, generation 1, you can look out populations that experienced food adequacy or excess food. I mean, there is some human data on that. And there's some interesting data on quantity and exposure to B12 and folate, in utero and birth outcomes. Actually a U-curve, an interesting U-curve out of Johns Hopkins, associating it with increased incidence of autism and possibly asthma.
It brings me back to your kind of the original question we started this talk about, which was around the estrogen metabolism and looking at methylation. And it gets me thinking, like, your hierarchy concept is really interesting. And have we looked ever before at the patterns that we might see in a more toxic population or a more stressed population? Because
You
that
have
what you're
that.
proposing, Kara,
Yeah.
makes me think that if estrogen metabolism was not the primary, place for methyl donors to go in the hierarchy, there could be other factors beyond, just the adequacy of those nutrient donors that would affect methylation on our test.
Yeah, for sure.
Yeah.
Yeah.
Well,
Yeah,
a
you could.
lot of toxins have phenyl groups, and then you end up in that same need for methylation to get rid of whether it's benzene type compounds and all of those. One of the questions I've got that's related that I wonder if you could shed some light on is, like, I'm a good example. I have this COMT defect, right? So if I take methyl support, it gets better. It's hard to get it to really move the meter a lot. So if I just am narrowly focused on that and I overdo it, and so I'm just methylating the crap out of other things potentially.
Yes.
I don't know,
Yes.
but my estrogen's still struggling. So if I'm overdoing the solution to that problem by adding methyl donors into the mix, et cetera, then if I then move my focus back to epigenetics in that world, and I've put, my gas is maybe the wrong analogy here, but if I've done too much
Yes.
to push that, so what is the consequence
Yeah, that's a
potentially
really good question.
of excessive methylation on that front,
Yeah.
while I'm trying to affect something that's still struggling with undermethylation?
And what would the solution be? So there is literature out there, suggesting, and this was another one of our original concerns and questions. Our field a while ago went through a phase of really aggressively prescribing methyl, right?
Oh, yeah.
Very high dose folate. Maybe it was folic acid, and then we started using, bioidentical
Grams and
folates.
grams of it.
Grams and very high dose B12. And that was a piece of our original research question, like, could you be pushing methylation aggressively forward? And I think that the answer is, yeah, I think it's possible. So going back to aberrant or imbalanced hypermethylation and going back to these tumor suppressor genes that can get methylated and inhibited, or that John Hopkins paper where there was a U curve. So, higher levels of methyl donors in the blood of the pregnant women had some negative outcome in offspring, as did deficiency. So the literature is clear that insufficient methyl donors is a massive problem for many reasons.
Sure.
And cancer being one of them for sure, like DNA repair and all of the important things that methyl donors do. But excess, there is suggestion that it could also similarly play a role in driving forward some conditions. In particular, one that I talk about in the book is cancer, and perhaps a piece of the mechanism is through hypermethylating tumor suppressor genes that protect us. So I think there's reason to be cautious about these uber high doses long term. Like I think we were getting into uninformed habits back in the day, and I think we have since become a little bit more measured, but we were going very aggressively. And so I want to say there are times when we need to. I mean, for instance, cerebrofolate deficiency, individuals require a higher dose, a higher amount of folinic acid to really make sure there's adequate folate entering into the, just getting across the blood-brain barrier. There are appropriate reasons for using it. And we also want to think about, can we get this from food? Because you can eat all the folate, and we increase circulating methylfolate in our participants without giving them any significantly compared to control. So we know we can increase through diet, and there is no negative outcome in the literature, on eating too many greens and jacking up your folate that way. So yes, if we have to go high dose, no, we're using it for this reason. We're going this high. We're going to do it for this duration. And then we're going to try a taper if we can. So that's thing one to think about. So don't leave it. Don't get too scared about what I'm proposing here and walk away from using methyl donors, because they're an essential tool in our toolkit, absolutely essential. And, pregnancy, to your point, is a huge one. The other piece that we learned extraordinarily that's ridiculously interesting to me is that these polyphenols, they're not participating in the methylation cycle directly, but they seem to have a role in directing how methylation happens, so that it happens in this clean, awesome, balanced way. in our study, for example, we didn't increase net methylation on the epigenome as compared to the control group, but we rearranged it to a more youthful pattern.
Fabulous.
Isn't
It's
that
amazing
cool?
to think about.
Yes,
Yeah.
and I think the secret sauce is the combination of methyl donors with polyphenols. So going back to your point, Mark, where you're working on your COMT and you're really wanting to improve estrogen metabolism, I think that that's awesome. I think you could do it through dietary pattern with methyl donors on top of that, and just, and make sure you're consuming those polyphenols. So a change for me in this science and just thinking about it clinically has been, if I'm going to prescribe somebody, a fairly aggressive methyl donor protocol, I'm going to make sure I'm backing it up with a nice mix of polyphenols.
That makes a lot of sense. And like what you are reminding me of, just the elegance of the biology to be able to rearrange, and, the interaction that we have with food and with our environment that are so critical. We only have about a couple minutes left. I want to bring it back to your book again. If you guys want to learn more, we'll put the link in show notes to get Dr. Kara Fitzgerald's book, Younger You. If you could give a couple of key clinical takeaways you hope clinicians would get when they read your book, especially in context of Dutch testing, what are the things that you wish they would really take away from the book?
Thanks. That's a good question. So you are going to get a nice snapshot of methylation outside of the DNA, using the Dutch test. I think that it's absolutely essential to see that we're doing it cleanly. I would say that if you see imbalances, which is ridiculously common, you may then turn the volume up and look at homocysteine and dance around the methylation cycle and infer that it is possible that epigenetic methylation is not optimal, given what you're picking up on the Dutch. So I think the Dutch could be a nice entry point for people who aren't thinking about epigenetics to kind of think about it. We just talked about methyl donors. Supplementation is absolutely indicated in certain cases, but you can do the dietary pattern and increase methyl donors and improve outcome in the Dutch test. We prescribe the Younger You dietary pattern. We prescribe components of it to all of our patients, and we also obviously use the Dutch, with the vast majority of our patient population as well, with or without methyl donors. So we have data in both cohorts, and this will move the needle and help favorably augment, some of the imbalances that we routinely encounter. So we can use it. What would I say for clinicians? So don't forget the power of the diet. It really works. We don't always have to immediately go to a supplement. We can start here. We can come back to here and move away from the supplements perhaps sooner. So yeah, I would do it. And just since we are talking to clinicians, there's a brief section in the book. We have much clinical experience doing this. So I included a table of modifying the Younger You dietary components in SIBO, and in celiac, if you're going to do it with an elimination diet, if you want it keto leaning, et cetera. So common kinds of conditions or dietary patterns we prescribe in practice, I covered in the book because we just have a lot of experience.
Wonderful. Dr. Fitzgerald, thank you for your commitment to functional medicine and the way that you've advanced the field. It's inspiring, and we're really lucky to have you as a part of our Dutch family, and also just here on the podcast today. So thank you so much.
Thanks for having me both.
Thanks, Kara.
And Mark,
Thanks.
so glad you should be on the podcast more because it's really fun.
Yeah.
Yes, we can nerd out.
I'm lucky. Yeah.
It's so great.
Thanks for joining us on the Dutch Podcast. Join us every Tuesday for new conversations with leading functional health experts. If you like what you've heard, be sure to like, follow, and subscribe wherever you get your podcasts.